Welcome to Fragmented, a software developer podcast where we talk about building good software and becoming better developers. My name's Donn Felker.
And I'm Kaushik Gopal.
Welcome to the show. Before we get started here today, I wanted to tell you about the relaunch of AndroidJobs.io. Android Jobs is a job board that I launched many years ago, and I just recently relaunched it with a brand new design and on a brand new platform. If you're looking to hire an additional Android team member, or you know of somebody that wants to hire an Android professional of any sort, that includes developers, designers, anything of that nature, then please let them know about AndroidJobs.io. All job postings are free at this time during the early release phase. Eventually they'll be paid, but right now they're all free at the time of this recording. So please go to AndroidJobs.io and you can post a job for free. Or if you're looking to see what other jobs are available, you can also go there and plug your email address in, and we'll start emailing you here very soon, letting you know weekly about the new jobs that are available on AndroidJobs.io. Again, check it out at AndroidJobs.io. Everybody, welcome back to the show. This week we have something a little bit short, but it's a topic that I wanted to talk about simply because I've been chatting with a number of developers through Twitter and Instagram and YouTube all over the place, and I've had a lot of discussions and also dealt with this a lot in my professional career as someone who's been consulting for close to 15 to 20 years now. And those things I'm going to talk about are the three things that every software developer needs to know how to do. And none of these are really groundbreaking, but they are something that can really help you on your day-to-day process in any type of software project. So this doesn't strictly apply to mobile developers or any type of developer for that regard. It could apply to mobile or web, could apply to someone who's building a car stereo API in C or some low-level language. All of this really applies. So without further ado, let's just hop into it. So what are the three things that every software developer needs to know how to do? Number one, you need to know how to identify premature optimization and avoid it. So what is premature optimization and what does it look like? Premature optimization is when you're trying to optimize a piece of code because you think it needs to run a certain way. It needs to be more performant than the perhaps naive way that you're implementing this. One really good example of this is perhaps you're taking a very long string or a number of strings and you need to concatenate them together to form one string. The common knowledge among the software community is that string concatenation in most languages is a slow process. So you shouldn't use any type of just general string concatenation where you're just concatenating the strings together with, the plus operator or whatever the method is, the language that you're using. You should use something like a string builder or a string buffer or whatever your language is that has the optimization for string concatenation. This happens a lot. I see this a lot in code where there'll be a little function that will build a string, and inside of that function, I'm going to use string builder as an example. It uses a string builder, which is a performant way to build strings in a number of languages. And inside of this function, it will use a string builder, and what will happen is it's maybe only concatenating 5 strings. But the developer who wrote it did it this way because they heard that this is the proper way to build a string that's very performant. However, it's more code to maintain than just concatenating 5 strings together on one line of code. And it could possibly not even give any benefit whatsoever that's perceived to the end user. And frankly, could be zero benefit perceived to the application whatsoever. And to give you a further example, let's assume that you have a page or a screen in your application that's the about screen, and you need to concatenate 5 or 10 strings together to display some information on that about screen. As most of us know who are developers, the about screen of any application is probably the least visited screen in any application. No one really cares that much about the application. They're there to use it because it provides value to them at some way in their life. So it's not really accessed that much. So if you're concatenating 5 or 10 strings together, do you really need to use something like String Builder? In my opinion, absolutely not. You don't even need to do it. Just do whatever is quicker and easier to maintain and get the feature done and ship it. Now, someone's listening to this, I imagine, and saying, well, yeah, that's great for the about screen and that's perfect for that scenario. But what about I have a social media app and we can need to concatenate a string in the main timeline, which is the main part of the application. And if we concatenate that many strings, I know it's going to be a problem. My argument here is you don't know. And that may seem a little arrogant, and it's not meant to intend to sound that way. But the only way I can say that is the only way that you're going to know is if you've measured it. And I have a saying that says, what gets measured gets managed. This is something that I didn't create. It's a saying I picked up a long time ago that I completely agree with, that we don't know if what we're doing is the right thing unless we have a way to measure it. So let's assume that same example where we have that string concatenation and we're going to do it on the timeline and we're going to scroll this timeline. And every time we scroll on the timeline, it has to concatenate these 5 or 10 strings. Do we really know if that's the worst part of the application? Is this non-performant, or is the compiler, or did the compiler perform some type of optimizations underneath the hood that makes that completely obsolete? So it makes it doesn't even matter. We don't really know unless we measure it. And so you need some type of way to measure that. And so that's kind of beyond the scope of these 3 things here. But if you can measure something and it does show you, hey, that this is the actual problem, then you know, all right, well, then I maybe need to fix that. So my argument here is don't prematurely optimize until you start measuring things. So you need to recognize when you're premature optimizing. This just doesn't go for string concatenation. This could go for something like over-optimizing database queries, realizing that you need to perform a bunch of different joins and so forth to save the couple extra queries that you might do through your ORM or through whatever. Maybe you're trying to write some custom SQL just so it's one database query and it's really fast. But you don't know, again, if that's really going to be the problem on this screen or not. So, in my opinion, write it so it works. Get everything working inside of your current screen, your current feature, and then see how it operates. If there's no problems, then why should you have to change it? If it's not performant, there's no jank or anything like that, I don't see a reason to have to change that type of thing. Now also, what you also find a lot of people falling into the trap of is doing something because they heard some expert tell them to do it. I've fallen into this trap numerous times, especially with the string builder example. And it's one of those situations where, well, I heard so-and-so say this and I highly respect their opinion and I must be right because they're respected in the industry, so I have to do it this way. No, you don't have to do it that way. I always will argue going forward that you need to get it done, then optimize it. If you spend too much time prematurely optimizing an application, a feature, a piece of code, you're just wasting time that you don't even know if it's valuable time that you're spending on this. You may end up finding out that that code runs just fine, but your actual problem happens to be latency with the server. So you need to solve that perception problem with the user. It's not actually rendering it to the screen. It's the API call for some reason is slow. So maybe you need to do some kind of fancy UI magic to make the user feel like something's happening and so forth. There's a bunch of different examples of this happening. And I have an example in my own personal life where this happened to me about 10 years ago. I was working in a client, a very big client that will remain nameless, that everyone has probably used their website. But I was building a system which was for a main component, what will be used on the homepage, which gets millions of visits a day. And this is a web app. And I was writing this code and I was prematurely optimizing this function. It might even have been with strings and a number of other things. And at the time, the lead sat down with me and he was looking over my code and we were pair programming. And he said, "Why are you doing that?" And I said, "Because that's the proper way to do it. We all know that if we don't do that, then it's going to be slow." And then he just goes, "How do you know?" And I couldn't answer the question. I said, "Well, that's just common knowledge." He goes, "But how do you know that's the slow part of the app?" I'm like, I eventually realized I was cornered. I said, I don't know that that's the slow part of the app. I'm just making an assumption based upon what I've read and common industry knowledge. He said, "Okay, well, I want you to undo that." He goes, "And then write it the easy way." And so I kind of argued with him for a while and I felt that that was kind of ridiculous. but I did it anyway. And then what we ended up doing, and he said, look, afterwards, we're going to run this thing through a performance metric tool, and we're going to see where the slow parts of this application were. And I was dead positive that that function that I made simpler and not as performant, the one I had optimized early, I was positive that was going to show up in this report. I knew it. Well, they ran the performance. I mean, they literally hammered this thing with a performance tool and got a bunch of traces on it. And the leads went through it and identified like the top 50 places in the app that needed to be refined to speed it up. My area wasn't even in there. It was halfway down, if not towards the end of that performance. And at that level, it was so negligible, it didn't even matter. What were the problems? Random queries to an API or to a database behind the scenes that weren't indexed. 80% of the problems were those. That just happens to be that application. So we applied indexes and things were working again. And we didn't even know at that point in time that those indexes were even going to be, that those database queries were going to be something that needed to be indexed. So we didn't know. We approach this strictly from the fashion of let's build this quickly. Let's use good patterns and practices, but don't over-optimize. So that's number one. Kind of long-winded there, but you need to identify premature optimization so you can catch yourself from doing it, because you'll waste a lot of time and you don't know if it's useful or not. Now, if you do know that your application is slow in this one area, and you do know that every time you guys do something on a particular screen in that part of the app, if you don't use this optimization, it will just slow to a crawl. Well, in that case, then yeah, use your optimization. That makes sense. But overall, you just need to make sure that you're not doing it before you have any metrics to which to dictate I should be prematurely optimizing or I shouldn't. So always opt for not prematurely optimizing. Again, there's a saying in the software community that's premature optimization is the devil. I would have to agree with that. So just kind of check to see what you're doing to make sure you're not optimizing early. Okay, number 2. This one would seem to be kind of common, but it's actually not common at all in software. And that is, number 2, you need to know how to write tests and what the different types of tests are. These tests include unit tests, integration tests, and end-to-end tests. So why do you need to know how to do this? I have worked at countless clients where I show up and there's no unit tests. There's no integration tests. There's no end-to-end tests. And in fact, if I ask if there's unit tests, every once in a while I might get a yes, and then what they would show me would be a end-to-end test, and I'd say that's not an end-to-end, that's not a unit test, that's an end-to-end test. And so I'd have to train the clients on the proper way to test and the different types of testing. So why do you need to know how to write tests? Well, very simple. Testing is what's going to validate that your software does what it does. It's a parachute. It's a safety mechanism for your software, because current me right now, I'm writing software that I feel is very good, and I'm going to write the software, and of course it's great. I've tested it myself, but the problem is future me doesn't remember what I did 6 months ago, maybe even 2 weeks ago, heck, maybe even 6 hours ago. I don't know. So what I need to do is make sure that I provide myself a safety net for future me and for future people on my team, if I have multiple people on my team. And what is going to happen when I write these tests is anytime I change something, if I inadvertently change something I shouldn't have or changed it the wrong way, a test should break and catch that. Now, this could be the input and output of something has changed. That's going to be your unit test, or if two different classes work, if I call into one class and it returns something different, that could be an integration test. Perhaps I'm changing the function signature. That would be an integration test. Tests would break in that regard. And perhaps an end-to-end test would catch something where I changed an API call somewhere, or I changed a serialization or deserialization method somewhere, and the whole app works fine, except when I run the full integration test to realize that, oops, maybe we didn't change it on the server, or maybe we didn't change it somewhere else, somewhere in the pipeline, and the end-to-end test is going to catch it. So overall, these tests are going to catch you all over the place and provide you with confidence that you can actually write your code. I'm sure we've all been in the situation where you write an application or you're writing some code and you need to ship it and you're afraid to ship it. And the reason why you're afraid to ship it is because you're not sure of what you broke. you don't know what you don't know, especially on a very large app. If an app has no tests and you have to write some code in an existing part of the app and change something, for me, I find myself getting very worried about, I don't know what I changed. I really get freaked out because I could change something that's really critical to the application and I might not even know it. And I could crash this for the company. I could crash this for all the users. Depends on how big the app is, how useful the app is. In fact, I know many stories of various companies in the Silicon Valley that had, these they called them like the God functions, where like that function is 2,000 lines long. It works. Don't touch it. And it was very impossible to put tests around it. And I heard this was actually a thing. This might be, tech folklore for all I know, but I heard this was the case early on at PayPal. There was a function that was very long. It might have been 2,000, 20,000. I don't know. It was a long function that was written in there. And its main purpose was to actually run the payment mechanism. And that was the core component of the payment flow. And you didn't touch it because it was very hard to test. It was almost impossible to test, but it worked. And anyone who had to get in there was fraught with anxiety simply because they weren't sure what's going to break. Now, if you have this thing completely covered 100% all edge cases and tests, well, that gives you a lot more confidence that you can change something. Now, if you're not really sure let's say rewind here. Let me say you're in the situation that I just explained. You've joined a company as a full-time employee, as a consultant, freelancer, whatever, and you get to the app and you realize, wow, this app doesn't really have any tests, or the feature I have doesn't have any tests, and I am terrified to change it. What do? Well, you need to write some tests around that, and that's going to be an actual end-to-end test or an integration test. Kind of get a test around the biggest piece of it that you're going to be working with. Now, it might be a screen that just outputs a certain value, and this doesn't have to be a perfect test. And this is outlined perfectly in the book called Working Effectively with Legacy Code by Michael Feathers, and I'll link that in the show notes. And that book literally lays out the chapters, and I've mentioned that book many times on this podcast, lays out the chapter titles like, I have a huge function and I don't know what to change and I'm afraid I'm going to break it. It's chapter titles like that are inside of there. I don't know, I have to change a function and I don't know where to start. And so it lays out all different types of things. And what he talks about is literally getting a test around that function. Maybe it's just a function where you test the input and output. That's easy. That's a unit test. Maybe you need to test that when I change this function, any of the consumers of the function are going to be correctly still operating. So I need to make sure I find out any of those places of where that's being used and maybe write tests around all those places. That could take a long time, but that will give you confidence. And maybe it's actually, you can't even do that. Maybe it's just impossible to even write a test. It's such spaghetti code. What do you do then? Well, what would a UI tester do? They would run the app and they would see what the output was. So maybe you can just run the app, grab a screenshot, and check the output. Now, that's not a perfect test. It's repeatable, but that will give you a little bit of confidence to know as you're changing things, all right, as I run this, cool. Is the output the same? Cool. If I run this, is the output the same if I change this? So those things work. Now, one of the things that you should also I should mention here is if you get into these weird situations where you have to write tests around something just to give yourself confidence to change it, realize that those tests don't have to stay around forever. That once you refactor the code and get it into a more malleable state, maybe introduce some interfaces, maybe introduce some type of dependency breaking mechanisms, which again are all covered in the Working Effectively with Legacy Codebook. At that point, maybe I can actually start running some much more fine-grained tests and get rid of that one really big clunky test that gave me confidence before. That's okay. I do that quite a bit. In fact, what usually ends up happening is I'll start with an end-to-end test if a client doesn't have one. The first test I'll write is, does the application just start? After we build it, can I start the application and hit the main page, and can I read some text off the screen? For a mobile app, that might be the home page or the login page. Does the login page even render? Does it crash? That's my first test. The next one might be, can I log in? Now, I'm not testing the actual functions and anything like that. I'm just testing, does the app do what it's supposed to do? Maybe I'm supposed to change some part of the login mechanism where now, instead of talking to one server, I have to talk to two for whatever reason. So I have to split the API calls. I have to wait for both of them to be returned before I can log someone in. So I'm going to go write an end-to-end test before I write my code. All right, here's what it looks like before I log in. Here's what it looks like after I log in. Do I get the same flow when I'm done? That'll give me confidence to actually write the code and make the change. Now, later on, I might go back through and refactor and do a bunch of stuff and then be able to test them independently. And then I can get rid of that big test and that's fine. So just to recap, we need to know the difference here. You know how to write tests and you need to know how to see what the different tests are and know the difference between them. So let's talk about unit tests versus integration tests versus end-to-end tests. Unit tests usually, and this is going to be paraphrased. Some people are going to disagree. That's fine. This is kind of one of those muddy topics, but this is my interpretation of it. A unit test is very black box. This is going to be an input and an output. I have a function. The function takes a value and it returns a value. Does the input and the output do what I expect it to do? That's a unit test. I can test this in isolation. It doesn't need to have a cloud working or anything. There's no external dependencies. It's very, very isolated. So it's really easy for me to write these tests. These tests are going to be the fastest tests simply because they can just fly. The next one is an integration test. An integration test is going to be a test where two components are integrating. Now I can say I'm using the word component here because that could mean two different classes, could mean two different applications, could mean a whole bunch of different stuff. So it's a very generalized term. But an integration test, let's just take a simple example, is when I call a certain function, I expect that other function to call another service. Now what that could mean is I have let's consider it a layered architecture. And when I click in a login class, when the login function is called, I expect it to go call the login service. And that login service actually has another dependency, and that one's going to call into the login facade, which then delegates to a bunch of other stuff. Now, I don't want to test the actual facade, so maybe I've used a mock function to test that out, and I've used mocks. That's fine. I want to actually test it when I've actually called into the login service, that the login service actually still does call the login facade, because that has to happen for some business reasons. So I'm just going to check that, hey, did the service get called, and did the service actually call into that mock facade there? And that might be a signature. I want to make sure that was called, and it should fail. If I go and comment out that function call to the login facade in the login service, well, now that integration test should fail. And what that's testing is that did the components integrate correctly? Am I integrating everything as I expect them to be? Again, there's going to be some arguments around this about if that's a true integration test. There's a bunch of different ones out there that you can talk through: system test, integration test, whatever. We're just going to go very general here. So integration test is anytime you're going to be integrating different components together. These will usually be pretty fast as well, because if you need to talk to any type of external service, sometimes most of the time, in my own experience, I will mock them out and verify that the mock interactions have happened. And that's me testing the integration. That's verifying the mock interactions. Now, what we have at the end here are the end-to-end tests. Sometimes these are known as system tests. And these are the tests that will test things from end to end. This is usually going to be, if it's a mobile app, you'll fire up an emulator. You'll actually log into the app. You will verify you see certain things on the screen, that actual button clicks happen, and you're seeing how things would happen for the end user. If it's a web app, very similar, but just in the web component. Maybe you're using a headless browser to do the testing, but that is what it is. Now, a lot of times with end-to-end tests, depending upon the company and how they want to do it, there might be an actual server that's fired up just for that environment, just so it can run and test that environment. However, anytime there's any external dependencies involved, tests do become very flaky. For whatever reason, the network just decides to time out, and now your test broke. These can break down your confidence of your system. So what ends up happening a lot of times with end-to-end tests is it'll be an end-to-end test all the way up until the actual application needs to leave its boundary. That boundary is going to be the network, it's going to be the file system or whatever. And at that point, certain mocks will take over, or fakes. say, hey, this is a fake API, and it returns a set of data that's expected in that scenario. This will make it very hermetic, so we can actually just repeat these tests over and over, and we don't have to worry about the actual network going down or anything of that nature. These will make it much more reliable, which then in turn will increase your confidence that you did not break anything when you wrote your code. So to recap, number 2, make sure you know how to write tests and what the different types of tests are. This includes unit tests, integration tests, and end-to-end tests. Okay, number 3. This one is going to be, I fought with this one internally, but in my opinion, this one is very important strictly because in my experience with it, it has made me so valuable as an employee and as a freelancer and as a consultant. It's something that's on my resume that when I come into a client, I can instantly make their development teams and environments just so much stronger and so much more professional with this simple thing. And number 3 is you need to know how to set up a continuous integration server. So a continuous integration server, what is it? It allows you, when you check in your code to your version control system, which we're going to assume is Git, when you check that code in, the continuous integration server sits off to the side up in the cloud somewhere or internal in your network and watches that repository and says, oh, hey, there was some new code pushed to that. Let me pull that down. And it's an automated thing. Let me pull that code down and I'm going to go ahead and build it and run all the tests. And I'm going to make sure everything is good. And if it's not, then I'm going to send out some alerts to some people, usually through email or maybe a chat message or something like that. So you need to know how to set these things up. Now there's different services, which I'll cover in a minute, and different self-hosted options that I'll talk about as well. But the bare minimum that you need to know how to do as a developer, freelancer, consultant, whatever, is you need to make sure that you can set up the continuous integration server. Then you need to make sure that it can actually build your apps. Now that's if your app is compilable. If it's a compiled language like Java or C# or something like that, you'll want to make sure that your build server will execute that build script to create the actual binary. So that's step 1. Then number 2, you need to make sure that it will run all of your tests, which would be step 2. So compile, then run all of your tests. Again, if you're running a interpreted language, maybe JavaScript, Ruby, Python, something like that, and can actually build it, you want to make sure that it's installing all of your dependencies beforehand so it's ready. And then you want to run all of your test suites after that. Now, this is going to include your unit tests, your integration tests, and your system tests. It needs to run all of those. And this is going to happen on every single one of your commits. Now, we'll get to the testing here in a second, but just assume we're running all of them. Now, finally, after and if the build succeeds, which is the compilation of your binary, and the tests succeed as well, the test suites are all passing. At that point, it's going to deploy the artifacts of your actual build. And that's going to be usually your binary and perhaps any of the reports from your tests that you have. That'll deploy off to a folder somewhere. Very often it's just right there on the build server, or it could be on like an S3 bucket or whatever. Just somewhere where you can get to it is all that matters at this point. You can optimize that later. And at that point, that's the bare minimum that you need to know how to do. And of course, there's going to be alerts that are set up that should kind of be a general thing. So maybe we'll add that as an additional one, is make sure that the alerts are set up. So if it does break, it emails all the team members. That's the bare minimum. Now, there are many advanced features of continuous integration servers. That's going to be such thing as like auto deployment. If you have a mobile app, maybe it auto deploys itself to Google Play or the App Store based upon certain criteria. Or if it's a web app, automatically deploys itself to Heroku or whatever your hosting service is, AWS or anything like that. There is also a ton of other advanced CI/CD pipelines, which is continuous integration, continuous delivery pipelines that you can get into. However, again, those are advanced. I'm not talking about advanced stuff right here. The bare minimum we're talking about is compiling your app, making sure your dependencies are installed, running in all of your tests, deploying the artifacts, and then any type of notifications for build failures. Now, why is this important? Because very often I have found when I go to companies, they're usually small companies, there is 1 or 2 developers there and they work together. They build the application themselves. There's not really problems. They don't need a build server. However, once your team grows, even beyond 1 person really, you can run into the situation, and I'm sure you have, where someone changes something and it works on their machine, but it doesn't work on yours. Why not? Well, maybe they changed something and forgot to check it in. The build server is going to be your source of truth. It's going to actually be the one who checks everything that's checked into your code base to verify that, hey, this does still build, all of our tests pass, and everything's good. Now, if it doesn't, if it can't complete all of those steps, what it does is it fails and lets everyone know, hey, looks like this build failed. Now, if you've used GitHub or Bitbucket or GitLab, you've seen a lot of these build systems already built into these platforms, and you'll see a lot of open source libraries will have builds enabled, and you may have seen a failed build here or there. What that allows you to do on these platforms, which we'll get to in a second, is dive into what was broken. You might find that a unit test broke or an integration test broke. These are going to be the safety mechanisms for you to realize, like, oh, I changed some code in this function. I didn't know it was used by this other place over here, and I can't return that value because, and you just kind of go down that whole path of realizing what happened, and then you can dive into it and fix it. Catching your errors this early on is much cheaper than catching them in production. You have to trust me on it. Catching them in production is the most costliest mistake you can have. So a continuous integration server is going to save you and your company time, money, stress, effort, everything. Yes, it's going to take a little bit of time to set up. Yes, it might be something new for you to learn. However, if you can set up a continuous integration server and build it and get it running with the proper build scripts, you become very valuable to your team. You might be the person that they rely on for all the build stuff. That could be a good or bad thing if you don't like it. However, as you progress through your career, this should almost be second nature for you. If you show up to a client, they don't have it, just set one up. For me, that's exactly what I do. In fact, if I go to a client and they need me to build them a web app or a mobile app, I ask if they have continuous integration. Half the time, they don't even know what I'm talking about. So I'll just set one up for them on one of the free services that I'm going to list here below. If they have one already set up, then I'll use theirs, or I'll have their team set it up for me if they have a team for that. So this is going to change for each different platform you're working on. If you're building an Android app, you need, Gradle scripts. You need to know how to run Espresso, emulators, stuff like that. If you're working in Ruby or Rails, you'll need to know how to work with, RSpec or Minitest or anything like that, and headless browser testing. So it just changes depending upon the platform you're working in. But there's tons of information that you can Google on how to set one up. Now, what are the different services that you could use to set these up to have experience? Any of the version control companies that are out there, the big ones, have build servers built into them now. Now, it always wasn't like this, but now it is, which is awesome. So if you're on GitHub, you can use their build servers. They have GitLab has build servers, Bitbucket, Azure DevOps. So those are kind of like the big ones that you're going to have there right out of the gate. So if you're hosting your code anywhere in there, you can most likely, and I do, use their build services just simply because it's already easy to set up. It's already integrated into the platform, and I don't have to worry about additional work of firing up another server on a VPC somewhere and managing that whole thing. I don't want to do that. I want less work. Now, there are also other third-party services that are outside of these platforms, which I've used as well. Companies like CircleCI or Bitrise or CodeMagic. There's a bunch more out there. You could Google build server for whatever your technology is. You're going to find a ton of them. But like the ones I mentioned here, CircleCI, Bitrise, CodeMagic, etc., you can go there and they'll actually plug into your version control system. And some of them provide different types of things, such as, hey, this is one supports Flutter and this one doesn't, and this one supports Erlang and that one doesn't. So you just kind of have to look around for what you like. And those are the services that are hosted outside of the version control platforms. So you can use one of those as well. Now, if you are in a situation in which you need a self-hosted solution, in that situation, you're going to want to make sure you know how to install and configure your own. This is a lot more work, a lot more intensive. However, if you can do it, again, you're going to be much more valuable to your client or to your employer. And what are the self-hosted options? Again, there's many, but I'm only going to recommend two here because these are the two that I've used in depth. Number one is Jenkins. This is the industry standard that you're going to see all over the place. If they're not using a built-in service, most likely a company is using Jenkins. The only other option to that I've seen a lot is a self-hosted TeamCity installation, and that's by JetBrains. Now, again, there's actually a bunch of other ones out there. I've used ones like cruisecontrol.net for many, many years ago when I was doing .NET development. I don't even know if that's still a thing. but there's many of them out there. But if you're going to self-host, look at something like Jenkins. That's literally the power horse of self-hosted build servers for continuous integration, or you can take a look at something like TeamCity. So when you have the ability to set up a continuous integration server, you're just going to end up being more valuable to your company. You're going to understand more of the process from start to finish of building the software and managing a software development team and life cycle. It's just going to help you out in the end in your career. So that's it. Those are the top 3 things every software developer needs to know how to do. Let's quickly recap them. Number 1, you need to know how to identify and avoid premature optimization. Number 2, you need to know how to write tests and what the different types of tests are. This includes unit tests, integration tests, and end-to-end tests. And number 3, you need to know how to set up and configure a continuous integration server so that it builds your apps, installs your dependencies, runs all of your tests, and deploys the artifacts and notifies anyone of any build failures. Now, there's a ton of other things that software developers need to know how to do. But in my opinion, these are some of the things that can give you an immediate benefit to your career over the long term of whatever you're working in and whatever industry you're working in. These things will always be valuable and have been valuable for me for close to 2 decades now. I hope that stuff helps. And again, if you guys have any questions, feel free to go ahead and send me an email or send me a message on any of these social media platforms. I'm just at Donn Felker with 2 N's on all the platforms, and I'll see you over there. And as always, everyone, thanks for listening. We'll catch you in the next episode. Hey folks, before you get going, don't forget to check out androidjobs.io. All job postings are now currently free during the early release phase. And if you're looking to see what other jobs are available, you'd be surprised at some of the jobs that are out there. Almost all of them are remote friendly. Tons of great companies posting there. You can sign up and get notified of new job postings on a weekly basis. Check it out at androidjobs.io. Thanks.
That's it for the show, folks. Fragmented is hosted by Donn Felker and me, Kaushik Gopal. We edit and produce all the episodes here on Fragmented. You can find more Fragmented episodes at fragmentedpodcast.com. Thanks for listening, and we will catch you in the next episode.